Okay, so now our next lecturer is Israel. He is AI engineer and data coach at Join Momentum. And this tutorial session is named Unlocking the Power of Language, a beginner's guide to natural language processing and text analytics. This session is an immersive introduction into the transformative world of NLP and text analytics. At beginners, it will cover the fundamental principles and methodologies that enable machines to understand, interpret, and generate human language. Attendees will learn about the processing and analysis and textual data, from basic pre-processing techniques to the application of machine learning models for tasks such as sentiment analysis, topic modeling, and named entity recognition. Through interactive examples and hands-on exercises, attendees will gain practical experience with the tools and frameworks that drive NLP today. This session promises to demystify the complexity behind NLP and text analytics, providing participants with the foundational knowledge needed to begin leveraging the power of language data in their projects. I will now turn off my microphone and camera. So Israel, the floor is yours.
All right, thank you so very much for the brief intro to why we're here. And that's so awesome to hear. All right, great. So good everyone. It's such a privilege to be on this call at a time like this, and thanks to the organizer for giving me the privilege to share a little bit of my experience and the stuff that I've been doing around the NLP space. Also, I like to also drop like a link to the repo where we have some of the materials that we'll be working with. I don't know if it is possible for me to see comments from the participant. I hope that, because I like to always ask questions to be sure that we all, on the same page. Okay, I think I can see comment. So I'm dropping my link to the repo. So you might also want to clone that. Then, you can use some of the stuff we'll be working with. All right, so I said, my name is Israel Odeajo. I'm from Nigeria, and it's an awesome privilege speaking on this call. And we're actually going to be diving into the possibilities of natural language processing. We're going to look at 2 or 3 use cases for, using natural language processing. But before we do that, maybe on the chat, you just want to tell me, is this your first time, hearing about NLP? Just want to know and have a sample of the kind of people on the call. Maybe that could also help us in the conversation. Okay, are you just a beginner? You're an intermediate person? You could just do that on the call, on the chat rather, so that I could possibly, have an idea of the kind of audience we have on this call. We can do that in 1-2 moments just to check through that. So you could just, on the chat, we'll just, pick that up and know the kind of people, the experts that I have on this call. Maybe that could also help in our conversation. All right, so as mentioned, this is the link to a repo you might decide to, so this is the approach. If you open this, so I want to believe that you do have a GitHub account where, you possibly have been storing some of your work as a data expert, where people can also access what you're doing. So I believe you do have that. So if you have that, it will be a bit, easier. Okay, some experience beginner. Okay, thank you for that. Okay, so I believe that you possibly have had time to check through this. Of course, I believe that the recording also will possibly be made available later when the entire conference is over. So this is the materials we're going to work with. I've named it DSC ADRIA 2024. So we have a number of materials, and at some point we're going to use a number of them as we move on. Sorry, team support. Are we making an attempt to record this section? Just want to be aware. just hope that folks could pick. I'm just trying to get that through and be sure that I sent. All right, great. So I think we can start now. So as mentioned, my name is Israel Odeajo. I'm from Nigeria, and I work with an AI company in the UK, where my role primarily is to facilitate trainings like this and also support the technical team, specifically on generating insight and of course leading, the AI part of most of solutions we are building. One of the projects that we're doing presently, that has to also do with NLP, as we're discussing here, is a job stimulator AI system. And what we're trying to do with this is that we know that a number of people, across the world are trying to like get, job opportunity, gigs opportunity, and of course they need to go through, interview stages, and this might take a long of time. So we're saying that we are building this AI system such that it gives, the student, access to their platform, then send them technical questions. And when these technical questions has been sent, then you now then have the AI system that is able to like give feedback in real time, using leveraging on natural language processing model API, whereby it's going to able to like check what the person has built and then give a grade to that what the person has done, and of course also give feedback on how the person can improve the solution that they are provided for that technical interview. So, it's once again an awesome privilege to be here. So we're going to be talking about natural language processing. And like we know, natural language processing stands for NLP, which is a branch of artificial intelligence that gives machines the ability to understand and process human languages. Human languages can be in form of text or audio format. So one thing to note is that as human from different background, different ecosystem, different space, we primarily, have different way that we interpret things, and we see things, or we hear things, or we write text, and all of that. Different languages, different, thoughts around, several words and all of that. So what we're doing at this stage is that we're trying to empower the computer to like understand, some of this context that we as human might understand, while they might not understand it. So we have to train the computer to understand, these use cases, right? And of course, for us, and of course, for somebody who is going to like start NLP, you must have, over time, be someone who has been doing a bit around the data space. Maybe you've been an analyst, or you've been, a machine learning engineer, whereby you've been working more with tabular data sets. But here, we're not going to be doing just tabular data sets. We're going to have a part in the data that is going to be textual. Textual means that a combination of several strings is what you're going to have, at those points. So our real job, of course, in most of the tasks we're going to do today is going to focus on text. And of course, as you begin to drive, better and deeper in your journey doing NLP, you might want to do a lot around also audio format, whereby you might want to, translate a text to audio. I want to translate an audio to a text. These are, several, other things that you might intend to do as a data expert, and even as you begin to build your career in the data space, right? So a bit about the history of NLP. NLP language, natural language processing. Of course, we say it's natural because it is the language some people are speaking. It is the language some people understand better and all of that. So that is why we could talk about the naturality of this language. And so our role as an NLP expert is to be able to like process, this, language naturally. So a bit of history is that it has been, evolving as far as 1950, where Atlan Matheson Turing published an article titled Computing Machinery and Intelligence. This foundation work is based on artificial intelligence and discusses the automatic interpretation and generalization of natural language. As technology has evolved, different approaches have emerged to deal with, NLP tasks. So just to bring it to light, the possible, use cases for using NLP as a programming, approach, or as a tool, depending on which approach, or as a solution. One of them is text-to-speech processing. So an example for this will be a voice assistant. So we've possible add about Alexa, we've possible add about Siri. You speak something, it does stops, within your building. It helps you search for stuff on the internet and all of that. So another key thing is another use case or application for natural language processing is text classification. So here you talk about the possibility of using Grammarly, whereby you write a word and it feels that this word is not correct, or is wrongly spelled, or does not exist. Even your Microsoft Word, you type words, it asks you to add to dictionary, helping you to like classify the word to a language that it understands. Your Google Docs, also do a lot around that for you. Another key part is information extraction. And of course, you can, take note at that point, your search engine, like your Google, your DuckDuckGo, these are like some of the tools you can think of. Also, your chatbot, and question answering systems. All right, just like every website, most of our websites you've possibly seen as a website bot, as a chatbot that can interact with you even as a person, and all of that. Also, we talk about language translation. Yeah, one of them is the Google Translator that a number of us have worked with, or other, localized translators, whereby it's translating from one language to another for easy communication, across board. Then we talk about text summarization. Of course, you have several couples of documents, several details are in there. And one of the things you really do want to do is that you want to like say, can you summarize this to me in 1 or 2 paragraphs? These are the possibilities of what NLP can do. And of course, if you've been, using all the new LLM systems we have, for example, ChatGPT and all of that, you will have at one point written something and ask it to summarize that for you. NLP, is powered to do tasks like that. All right, so we begin to talk about some, basic, context or concepts that we need to understand to be able to like explore the possibility of NLP. And one of them is going to be what we call regex, which is regular expression. So it is one of the, stops you must be able to do as you begin to do amazing thing, around doing NLP as it were. So, I'm going to recommend that you need to learn a lot around regular expression, because every of the strings that we're talking about has a pattern, and this pattern, has several ways of interacting with them, finding information from it, replacing information from it, removing information from it. So regular expression is one, big concept that you want to like pay attention to in doing NLP as it were. So let's look at the possibility of doing regular expression using, so I have a number of examples to explain this concept to us. So to use regular expression, which is generally known as regular regex in Python, we first need to like import the regular expression module. So let me also say that I am actually running my code in a Google Colab environment, which I possibly believe that a number of us are familiar with. So if you don't want to run your code, locally on your system, there are some computing, platforms where we can actually run our code. So what I did here was to first download the entire, stuffs from this, more like cloning what you have in this working directory. Then when you have this on your local system, you can, it's going to be a zip file. After you work with this zip file, then you want to unzip it. Then when you unzip it, you're going to have access to all the documents inside it. Then you come to Google and possibly just search Google. Just want to be sure that you got we work here. So Google Colab, known as Google Collaboratory, is Colab is hosted on Jupyter Notebook services that requires no setup to write or provide free access to computing resources, including GPUs and all of that. So it makes it like very easier for us to run our code. So if you go to codelab.google now, so I'm opening the first link. So I'm expected to like, if you want to read about it, you can definitely do that. So I'm just going to click on new notebook because I want to like work with the notebook. So one good part with this is because it's owned by Google. So if I add my Google mail, active on my browser. So I mean, most times we recommend Google Chrome, because I mean, it's a browser that works more with tools like this in respect to the extension and all of that. So all I just need to do at this point is to come to File, because I already have the notebook somewhere. So I'm going to click on upload this. All right. Why am I clicking on upload? Because I have this already on my system locally. So I'm going to click on browse. So the next thing to do is to look for where I have the file. So mine is here. So I'm going to just open, what is the file? DSC manual tutorial, for example. All right, so you have this, up. Okay. So if this is up, good. So when you have, the next thing you want to do is that you want to connect this. And this is what gives you like the power to be able to do a number of things. So it takes a bit of time. And don't forget that this environment actually expects internet access. So before you can use this. So now that it's done, so it tells me that I can start, running my code and all of that. So I believe that a number of us also is familiar with Google Code Lab. Please, can you just let me know that you got this on the chat? So I mean, it's easier for me to like, know if you have any challenges, working with the labs, material and all of that. Have we been able to, I mean, just a yes will be fine. Have you been able to access the link to where we have the materials? Have you been able to like clone it if you're trying that? Have you, I mean, do you get how we got to the Google Colab environment? Maybe this could help me, to be sure that, you're getting up with some of the things I'm saying. I'm checking through the chat, but I can't see any information or anything. Okay, I guess I just take it like we got that, since no one is dropping anything that I can see. All right, great. So thank you guys. So this is how we got to this stage. So I'm going to be sure nobody's missing on how we got into that stage. All right, so like I mentioned, one of the key things you want to like try out is regular expression. And let's see some of the use case for that. So below is a code in Python that, let me just close this so that I don't have so much running pattern below me. Okay, so below is a Python code spinet that demonstrates how to use regular expression to search for words pointer in a given string. It's then, print the start and end indices of the match word with the string. So like I mentioned, to use regular expression, you need to import this module called reg. So import reg. So now, I mean, this is a variable where we are storing these strings. We have Greek for Greek, a portal science, a computer science portal for Greeks. So I created another variable whereby I'm using from this regular expression, I'm using a module called search. I mean, what is search supposed to do? Supposed to find a particular string of what from S, all right? So it should tell us the start index match.start, then also tell us the end index match.end. Is the start of whichever, of the pointer, and the end of whatever it has found, which is the pointer, is what this code is going to do. So just trying to run that. So it's saying too many. So I mean, I just need to like stop some of the disconnect the runtime. Yes, so that we don't have too much stuff running in the background. Okay, so this is what we have. Just going to run that again. So when you search for Porter, so what are we searching for? Porter. So Porter's index starts at position 34 and it ends as position 40. All right, that's what we have here. Also, we talk about meta characters because for you to use regular expression, there are some meta characters that you might need. For example, here we have to introduce R somewhere here. We have to use dot match, dot style. So this is just to let you know that depending on the kind of problem you're trying to solve, or depending on the kind of way you want to use your regular expression, there are some meta characters that might be necessary for the tax that and there are a whole number of them. When you use this backslash, this list sign, this sign matches, this dollar sign, this apostrophe sign, they all have several meanings and of course use cases for it. So I'm just recommending that regular expression is a pattern that you might want to pay attention to as you begin to learn or leverage on your data preprocessing specifically for NLP. All right, so after that, we understand how that regular expression is important in what we're doing. So another, key preprocessing that you want to leverage on your NLP tasks or data set is tokenization. So this is like, here now we're discussing some, preprocessing you are expected to do irrespective of whichever data set you're working with, as far as an NLP task that you're trying to do or that you're trying to work with. Tokenization is one thing we are going to highly recommend, for you. And what does this talk about? This talks about a technique that involves dividing a sentence or phrase into smaller units. And of course, these smaller units are always known as tokens. So when we talk about tokenization, what should come to your mind is tokens. And of course, tokens can include a word, a token can include date, a token can include punctuation mark, or even figment of words. And of course, in this material, we're going to cover basic tokenization, some of their types, and their use cases. When should you use them? So like we've discussed tokenization again, it's a subfield of, in NLP, all right? And of course, this approach focuses on influencing, the entire workflow or your entire data set. So the tokenization is a process of breaking down your text into smaller units. And of course, we said these smaller units are known as tokens. And these tokens are typically words or sub-words in your natural language processing. It is a critical step in many NLP tasks. This can include NLP tasks like text preprocessing, processing, language modeling, or say even machine translation. Now, tokens serves as the building block for further processing and analysis, which enables the conversion of unstructured text into structured form suitable for the machine learning. All right. So the emphasis is that what we want to achieve whenever we are doing tokenization is primarily to convert our unstructured text or our very long text into structure one. And of course, we are breaking them down into smaller units, which we all know as tokens. All right. And of course, so we have several types of tokens. We're going to look at them and how to possibly use them. So there are several types of tokens based on our text segmentation. Like I mentioned that in this task, we're going to do more around, text data and not audio, video. These are more, complex and more advanced usage of NLP. But at this stage, we're just going to face text. So one way we can apply tokenization is what we call word tokenization. So let's look at what this does. This divides the text into individual words. Example, let's look at the input text that we have. Tokenization is an important NLP task. So the output is expected to break each of the words, all right, available in the sentence, in the structure, into tokens. Tokenization has been separated into a list, is has been separated, and has been separated, important has been separated, NLP has been separated, and tax, then full stop. That's why we said a token can contain, punctuation marks, dates, and text. So another one is the sentence tokenization. Now, this means that we can have several, texts in a sentence format or in your block of text, whereby you can now decide to break them down, into sentences. So you can only break down into sentences when you have, several, texts, as it were. So we have tokenization is an important NLP task. It helps break down text into smaller units. So with this now, if we use the sentence method, it's going to break, from this part, becomes like the first one. Then the second part will be, it helps to break down text into smaller units. All right, tokenization is an important NLP task. That's a first break. All right, then we have, it helps to break down text into smaller units. So you can see that from a text, we can break down into sentences. From a text, we can break down into the first part into word. Then the other one, from sentences or from a word, we can break down to small units. So if we have, for example, tokenization. So tokenization as a word can be broken down into token and ization. So this approach of doing token and breaking that token words into smaller units, all right, specifically just like a word into smaller unit, is what we call subword tokenization. Then we talk about character tokenization. So here we talk about dividing a text into individual characters. So if the input is tokenization, then breaking these guys down into individual character will be tokenization, right? So this picture shows how we can break down text into individual character by using character tokenization. So why is this important? So it helps us to play a crucial role in our NLP projects for several reasons. And one of them is specifically is effective for text preprocessing, whereby we are simplifying raw text from their easier preprocessing and of course analysis. So we can simplify raw text, for easier preprocessing and analysis. Also, it's easier for feature extraction, for language modeling, for information retrieval. We can also use this for text analysis, vocabulary management, task-specific adaptation, and of course, preprocessing steps. This is some of the use cases of tokenization. Now, in real time, so let's look at how we can do tokenization using, Python, because I believe that a number of us have some good knowledge about using Python, for analysis, using Python for, using building machine learning models. Then here we're trying to also learn how to use Python for text data, right? And that's what we're trying to do here. So the first step in, even doing NLP at all is that you need to first install a module, a library called NLTK. NLTK is Natural Language Toolkits. So this guy has a number of modules that will be necessary whenever we're working with text data. And that's one of the reasons why we are introducing, NLTK at this point. So, I mean, it's one of the modules. We have a number of other ones. We have Spacey, you have TextBob, but NLTK is like one of the most commonly used, modules that you can think of. So our first job is to first install this NLTK on our system or on, the environment where we are working. Since we are working on Google Code Lab, all right, so we don't necessarily have to, just trying to see if I can import something here. So we don't necessarily have to, okay, let me put it here, install that. But let's say you want to do that, but because you're using Google Code Lab, some of these libraries are already set up here. So it's going to be pip install NLTK. Then take note of the global exclamation mark, whereby it enables you to like install, these libraries within, this working notebook. So that's why we introduce this exclamation mark. So instead of having to install it maybe in a prompt or in your terminal, you could just basically, do the installation using this approach. So pip install NLTK is like one approach, that you can always use to do these tasks. So now, after you have installed it, like I said, we don't necessarily have to do that because the environment we are working with already has NLTK installed. So tokenization, yeah. So the first step is to install it. Then the next thing to do is primarily to now import this module or import this library called NLTK, all right? And of course, after we import NLTK, then we can download all the modules available inside of it. This is a library and we have several modules there, all right? So we do import NLTK, then we can download all, or specifically, we can download every library, every module that we want, depending on the kind of task we want to do. So this test may take some time, as NLTK includes a substantial amount of tokenizers, trunkers, algorithms, and corpora that needs to be downloaded using this approach. So understanding some key, terms and words that we might be using, moving on this lab section. So before diving into tokenization, let's clarify a few terms frequently encountered in NLP. So one is corpus. So a corpus is the body of text that is you have together, that is in a singular form, and corpora is the plural form of corpus. Corpus is a body of text that we've been working with, even in the simple examples I've been showing before now. Lexicon talks about a dictionary of words and their meaning. A dictionary of words and their meaning. And of course, token, of course, I've talked about token as the smallest unit of any word. The smallest unit of any word is what we call, token. So for us to do tokenization, and that's why we're using the Pocket here. Pocket method, it's a module in our NLTK that actually it's primarily one of his tasks is to be able to do tokenization easily, either for word or for sentences, So we want to import, the first thing is to import NLTK. Now, NLTK.download Pocket. Like I mentioned, we want to use a module that is necessary for the task you want to carry out. The question now is, how do I know which module to use for the task I want to carry out? And that's where your research plays out. So already you know what you want to do. So let's say I want to Google which module. I could just come to Google, say which module can be used for tokenization. So the emphasis that you have to know, with Python, the task you want to carry out, even if you don't know the module to use. And this can, empower your, research. And there are several modules that you can, check out, that could do that for you. So if you look at the tokenizer in Python, 5 ways to perform. So the emphasis is that there are several methods of doing all of this, but the real thing is that you must know the activity or the, the process you want to do. What exactly do I want to do at this point? And that's why we're building like what we call like a, maybe more like a static, approach of handling most, NLP tasks. Of course, with not all of them that we're going to consider in this tutorial, but at least to a good extent, we're going to have looked at, several ways of doing some of these things. And of course, we also look at about 2 other projects that you can use to, show that you understand what we're even doing at this point. So I'm going to import NLTK, and then, it's going to download this module that we want to use, pick Pocket, and that's what we have here. So a bit about Pocket is that it's a package in NLTK, which is a set of libraries and program for symbolic and statistical natural language processing. And of course, because we are working with Python programming language, the Pocket is specifically used for dividing a text into a list of sentences by using an unsupervised algorithm to build a model for abbreviation word that has already been done, collocations, and word that starts sentences. It is used for sentence tokenization, which means it can split your text into sentences. This is particularly useful for applications that involve NLP tasks like text summarization, sentiment analysis, and many others, where understanding the boundaries of sentences is important. So from this now, we can import this to say, from NLTK.tokenize, this is the module we are using. We want to import sentence tokenize and word tokenize. I've told you, we have several ways of tokenizing a sentence, of tokenizing a word. It could be sentence, it could be word, it could be subword, it could be character. But for this tutorial, we're going to, talk more about sentence, because in real life, in real terms also, you're going to possibly be working, with, say, texture that are already possible are going to be, couples of words together. All right. And the idea of sentence tokenize and word tokenize will be most appropriate at that point. So the text we're working with is natural language processing is an exciting area which budget has been allocated for this. So we know that this is a text we're working with. Then we introduce sentence tokenize, which is like an object, because we are calling a module called sentence tokenize on the text that we have. All right. Then we are printing the sentence tokenize to see if what we did, worked. So we can see that we have two sentences now. This is sentence 1 and this is sentence 2. So what we have done at this point is that we have been able to do sentence tokenization on our text data, sentence tokenization on our text data. The next one we're trying to do is word tokenize. That means that we're going to have just individual words, irrespective of the number of sentences that we have. So here we're using word tokenize. So you can see now we have all of these guys as individual words across our working environment. You can see the text now. So what we have done here is sentence tokenization and word tokenize. So I want to be sure that we are together and nobody missed the process. Can you please put a yes on the chat? Just helping me to track if you understand what we have said on tokenization. Or if there are questions also, I'm willing to look at the chat and pick them up. I know there's also a question and answer module where you can possibly write stops. All right, so I take it that we all got what the use case for sentence tokenization and what tokenizations are. Then we'll look at a more complex, situation or say approach in handling some of this. So we have a text, just trying to give a picture of say you have so many texts. Let's see if we're good with this. But maybe the way I place the character might be a bit funny. Maybe didn't even pick them as expected and all of that. But the emphasis of what we're trying to do here is that we're still going to use this sentence, all right, to get the sentence tokenized, to get the also the word tokenized. That's what we're trying to also show at that point. Also, another approach that we're trying to use, okay, I guess this was going to be a better way instead of using the slash. Maybe a plus was enough and not necessarily putting this guy. But already I have something like this already, done here so that we don't take time trying to fix the text I have there. So like I mentioned that we have several other, modules that we can use whenever you are doing NLP. We talked about, NLTK. Another module we can also discuss or look out for is primarily going to be TextBob, right? So TextBob also has, a number of modules that can be used. And of course, in using your TextBob, the first thing you possibly want to do is to pip install your TextBob. But like I mentioned, we possibly going to have some of these guys already in the environment that we are working. But in a situation where you don't have that, you want to try as much as possible to pip install it. Then you want to also, the module we're using there is the download corpora, right, which helps us to be able to use TextBob. But at this level, we're just going to, from TextBob, import TextBob. Like I mentioned, TextBob is just one of the many other, modules or libraries in Python that we use for NLP tags. So the text is still the same text as seen above. Then we created a TextBob object, all right, that takes all the text. Then from this, we want to get our word tokenized in a new line using the Bob object.words. Then the sentence tokenized, we have the Bob object. We want to take our dot sentence, which is going to split what we have here into words and into what tokenized and into sentence tokenized. So this is just, showing different approaches of doing your tokenization for any of the tasks or any of the projects you are working on, for any of the tasks or say any of the project that you're working on. And that's, one way of handling it. So I want to believe that we got that. I don't know, am I the one not seeing it? If we're on the same page on the chat, but I hardly can see anything. I don't know if it's from my end or nobody is writing anything, right? You want to be sure that I'm not missing anything out. So I want to believe that we understand the approach behind tokenization when you are working with NLP tags. All right, great. So another thing you might want to try out, let me be sure I have these guys somewhere. What? All right. So let's move to another processing that you might want to do whenever you're working with your texture data. So let me place a word here. Same here. Welcome to NLP lab section. DSC Mina 2024. Okay. So this is the word I want to perform some of this activity on. So we're going to say from NLTK. So what we want to do now is what we call stemming, and that's also one approach, that we might have, which is a bit different from tokenization. So yeah, what stemming helps us to achieve primarily is that it helps you to get, after you have tokenized a word, let's say that you have, let's say, for example, you have interaction. All right. The root word of interaction could possibly mean interact. All right. So that is exactly an idea of what, stemming helps us to do on textual data sets. It helps you to bring a word to its root form. You have, you have languages. So the root form of languages, for many of us who understand vocabularies, is going to be language, right? Because, that's like the root word of, languages. Same thing goes for a number of words. So that's like a picture of what we're possibly trying to, get from doing stemming. Stemming helps us to get the root form, not the root word, the root form, of a certain word, all right, which is available in the text. So one of the, stemming techniques that we can use is what we call Porter stemmer. So from nltk.stem.porter, we're importing, Porter stemmer. So stem now is that we're using the module called Porter stem. Now this is where it happens. So we're looking through for all the words in this guy. So for all the words in words here, we're picking every word here, and it picks every word. Welcome and try to put it into a stemmed format. Then we are printing every word in the stemmed. So if we print this now, can you see now? It's bringing every single word in the stem. So it's splitting them, so much out for us just to see them like in their, in their format. But let's say that we possibly have this maybe as a list of word or something. It will be a bit easier for us to see the possibilities that we're talking about. All right. So another module or another approach that we can use for doing stemming is lemmatization. Right. So lemmatization is, very close to what stemming is doing, but lemmatization is a bit more powerful. Why? Because lemmatization over time tries to like generate, vocabularies that can be found, in a dictionary. At times, your stemming, your Porter stemmer or some other form of, stemming that we could do might actually give us words that might not be found, in a vocabulary or in a dictionary as it were. But for the lemmatization, it tries to find like a word. So that means that there is a lot of word net that is happening, whereby it's trying to cross-check the words, before it decides to, give us a result for those, tokenized words. So lemmatization, like I mentioned, is a lot more powerful. It looks beyond word reduction and considers a language full vocabulary to apply a morphological analysis to words, aiming to reduce inflectionals, ending only, and to return the base and dictionary form of the word, which is known as the lemma. Right. So for us to use lemmatization, so we want to use a particular, module called WordNet. So WordNet is a public available lexical data set or database which supports over 200 languages, known for providing systematic relationship between words. As one of the easiest and most widely used lemmatization techniques, it is crucial tool in the field of natural language processing. Of course, one of the key features of WordNet, like we're doing, is that systematic links, sync sets, all right? And of course, the question now is, how do we use WordNet lemmatizer in Python? So easiest way, I mean, after we have our NLTK already installed, so we have to, from our NLTK, we have to download two, modules from it. One is WordNet, another one is Average Perception Tagger. So Average Perception Tagger primarily is used for doing word tag, whereby for every word that we have, can we declare the part of speech that word belongs to. So it could be a noun, it could be a verb, and all of that. So that's what. So, but for this lemmatization, we would need the WordNet to achieve that. So all we need to do after we are aware that we already installed our NLTK before now. So from NLTK, we are going to download WordNet. All right, so true. So from nltk.stem.wordnet, we are going to import the module called WordNet lemmatizer. So lemmatize is WordNet lemmatizer.lemmatize the word in our words. So it's going to print, the words that we have. But like I said, this is the words here might not give us like the approach that we are looking for. Maybe we could just have a list of strings, and maybe that makes it a bit easier for us to see the effect of what we are discussing. So let me make this like a list of strings. So welcome to intentionally I'm putting conferences. I want to see how it's going to lemmatize words like that and see what we have. Okay, good. So if you look at this, so that you can see the effect of the lemmatization that is happening. The welcome, you can see it has created a root word, but welcome without E does not sound nice. Two still remain DSC. There is no conferences has been, reduced to confirm. Happening, happen. I mean, that's correct. So you can see that, I mean, that's the difference between stemming and lemmatization. Let's see what lemmatization is going to do for the word that we have provided now. Let's see how it's happening. Can you see how lemmatization does that? Welcome is not changing to DSC conference happening now. So I mean a good number of the tokens that we have here seems to be in their correct form, apart maybe from happening, because I mean happen might not, be the best word next at this point. So you can see how this has been lemmatized, in respect to what we are doing at the moment. Just trying to, explain this concept. Okay, so as you also begin to, pre-process the data, one other thing you might want to also do on your data set is what we call stop words. So stop words are, they are words within our text that helps the text to have meanings, which might not be necessary in analyzing or moving forward with that data. So this is NLP class. This is NLP class. This is there, makes it easier, to express that text, but not necessarily that we need it for our analytical work or for the NLP project that we're doing. So one of the things we try to do is that we also try to, remove stop words from our text data. We try to remove stop words from our text data. So one of the ways to do that is that we need to also download stop words from NLTK. And that's what is happening here. All right. So from NLTK.corpus, let me also mention that stop words, we have about stop words for several languages. And for the task we are doing is English, it might be French in another, data set you're working with. It might be other languages in other, it has up to close to 200 languages too, that it can remove the stop words from those sentences. So it's important to take note that for now we are working with English, but for the ones you might be working with on other projects, it might not be English. So you might want to take note, of that as we move on. So that's what we have here. So the example sentence we're working with is here. Then we will set, our stop word after we have downloaded it to be seen as English, right? So this is the filter sentence here that says for W. So we're using a list comprehension to get all the correct one. So we're saying that for W, for W in word tokens. Now, what are word tokens? Word tokens are every word that we have gotten from this example sentence. All right, now we're going to have this is a sample sentence showing of this stop word filtration and dots. So this is how, because we have used word tokenize. So that means the word tokenize is primarily going to help us to get a tokenization of every word. So now for every of these word tokens that is not in their lowercase, so I mean possibly that's the first thing to take note, and it's not in stop words. So stop words are English words, like I mentioned. So if you run these stop words alone before even running these parts, let me bring this out so that I can see what the stop words are, especially for English. So you have a lot of them. So you have set it to English. The stop word not defined. Okay, I've not imported it, this part. All right. So from here now, if you check the stop words, okay, let me bring this down. So you tell the stop word, you're going to see the words that are available. So the possible kind of words is going to remove. So we have a lot of them. Can you see? These are the possible stop words that you have in English. And if it finds any of these guys in any of your sentences, it's going to remove them. All right. It's going to remove them. So these are the stop words. So you have a lot of them. All right. For the tags. So it's going to remove those guys from any word that you have. So if we do this now, so when it removes, so for any stop word here now, it's going to remove them. That's what is happening here. And that's why you're saying not. If not, that means if not, lowercase, and of course, if it's not a stop word, that is the only word is going to return. All right. So in our filter sentence now, we want for any word in the token, if not in the stop word, filter. So these are the words you want you to append here. So we want to see the word tokens and the one that it has filtered. So we are getting two results. So we have this is, I've said this before now. This is the word, that we have. This is when it has tokenized it. This is when it has did a word token to it. And this is when it has filtered it, removing stop words that are available there. Removing stop words that are available, in what we have here. So like I mentioned earlier, there are several other modules that we can use, to achieve all of this. So another one that we can use to achieve taxes like this is Spacey. Now, why am I introducing you to a number of these guys is that so that when you see them on different materials, you'll be aware that there are several, libraries, in the Python environment or say in the NLP world that you can use to achieve several approach. All right. And the reason why we're saying this is that some of these things will be like very genetic whenever you're working with any data set. We're going to try and walk through a real life project, before we finally, end the class. But it is still some of these, concept that I'm explaining, step by step that we also need to be able to explore those projects. Like I said, in case you just joined us, this is where we have the materials we are working with. You might decide to also clone this and use it. So I'm dropping the link again in case you just joined us. So you can clone this, and I believe you possibly understand how to load this on your Google Code Lab. That was said, when we started this section. All right, great. So we're using Spacey, and because we're working with English, so we are downloading a particular English module from Spacey called E_core web SW. The sample text we are working here is there is a pen on the table, and of course, we process the text into our Spacey this way. Then we are filtering it, to get some word at the end of the day. All right, so you can see, so the original text is there is a pen on the table. So after stopwatch has been removed, we are left with only pen and table. And I mean, this is a clear show of how you can use this module. Also, we decided to use here, decided to also use another module for stopwatch called dynamics. So this also helps you to, do stopwatch. So here we have from genix.pacing.preprocessing import remove stopwatch. That's the module we are using here for this. So the new text is the majestic mountain provide a breathtaking view. Remove the stopwatch using Texim. That's what we're doing here. So we're removing that stopwatch and we are saving into new filter text. So we want to get the two words, the original one and the new one that we have. Okay, so this is, something that is also very important whenever you are working on textual data. Also, if we move on here, another approach or another thing you might need on the tag is what we call part of speech tagging, which is generally known as POS tagging. So here you want, after you have gotten each of these words, you want to be able to say what kind of speech is this, what part of speech is it noun, is it pronoun, and all of that. But of course, this might be more, approach able or useful for people who want to do something around topic modeling. This is an approach that you might want to use, but we also used, this within this material. Then for us to use this POS tagging, we are using average perceptron tagger. We have to download that from the NLTK module because we will need it to achieve this kind of tags. Then from TextBob, import TextBob. So the text we have, so we also have the TextBob. So the method we are using here is .tags. So this tag is going to get all the words that have been, gotten here. So it gets every word and tells you, the part of speech that they belong to. All of this can be read through whenever you are checking through POS tagging. What's NMP mean? Of course, it's talking about noun, in what we have. Also, just going to show a little more some cleaning you might want to do on your data set, especially when you have this kind of data that has white space here, all right, that has, some special characters in there, and you don't need that because one of the things you must have successfully done is that you must have, tried to clean this data. You must have tried to remove all of this from the data. So let's look at what we have. So we have this string, all right? So what are the things you're going to do if you have data like this? The first thing is, whenever you're working with textual data, you want to try to convert every of the string into lowercase, because it makes it easier for you, because at this point, Python can be very case sensitive, and having a capital P and lower P will not mean the same thing. So the easiest way, or one of the key things you really want to try out is to ensure that you have all of your string in lowercase, and that's like the first thing, whenever you are doing your pre-processing, that you might try out, at your end. The next thing here is that in case you have some numbers that are not possibly necessary for your, for the kind of tax that you want to do. So we are using the regular expression. Don't forget, I told you about regular expression when we were starting, and this module will primarily help us to undo cases like that. So if you have this, so the next thing to do is to remove some of these, numbers that we have in the tax. So look at, from the regular, substitute these guys. All right, this is the meta character that we used. And of course, we're having a space as they replace for them here. So this particular pattern helps to remove all punctuation except for words and their space. Except for word and their space. Can you see that? So Python released, so it's becoming more cleaner and all of that. So the next thing is that I can see some white space here, which did not show that my text is in its right format. So if I want to remove, white space, of course, I'm going to continue from where I stopped, because the last activity I did was stored in no underscore punch underscore string, right? So the next thing I'm going to use is I'm going to use the strip method to remove, those space that I have here. So I think at this point we are good to go. Of course, I'm going to convert all my string to a list of words if I need to do that. All right, so this already gives a picture that now I can tokenize this guy. I can do a word tokenize, for each of these now, then move on. I mean, that's even what we have here. Then from here, I can decide to do my demonetization. From here, I can decide to remove my stopwatch. Just trying to give you a picture of, how a data can look like and how you can decide to clean it as an NLP expert. Okay, so same thing is happening here. We're removing stopwatch from this, word that we now then have now. And yeah, so primarily that's what has happened here. We removed all the stopwatch, so we're only left with the words that are needful. All right, good. So I mean, that's one thing to take note. Also, as we do our preprocessing, another key thing you might want to do is to get what we call bag of words. So bag of words is a picture of an activity that we do whereby we can get some words and know the number of times such word exists in what we are doing. So that's what bag of words basically does. It helps us to get some words. Here we have done sentence tokenization. We have tried to to do a lower method on all the words that are there. We have done sentence tokenization for this guy, and we store that into data set. The data set, we want to ensure that every item that we have there in the lower case, we're trying to replace also, some part of the text. We're trying to replace also, I've told you these special meta characters, they have their meanings of what they're trying to do for us. Now, after we've done this, the next thing we're trying to do here is that we want to create a dictionary, because a bag of words is going to have a key and a value. So the key is, in the bag of words, the exact word is the key, and the value is the amount of time that particular word, exists in the task that we are doing. So if we create the bag of words here, that's what is happening after we have tokenized and all of that. So if you check your, word count after this action has happened, you'll be able to see every single word that has been tokenized. Yeah, and you can see the number of times that word exists, or the number of times that word even showed in what you're doing. So these are the words that we have. The first one is being showed 2 times. Don't forget that maybe we are still having I because we possibly did not remove stop words. So that's one thing you might also want to add, after you have done this here for your word, right? That every of these things should also, remove stop words. Just trying to show you, the things you can do specifically when, so we need bag of words most time, because at times, also for people who are even doing, topic modeling projects, you might need those words to know, okay, how many times does this word exist in these tags? And I mean, it might also have, meaning, it might also have, something that will be useful for what you're doing. So this is how, we can do bag, of words in the tags you're doing. Also, another approach you might want to try out is DF, IDF. DF talks about term frequency, and IDF talks about inverse document frequency. So this is just talking about whenever we are working as a data expert, you must know that, especially when you have an intention of building a model, your data has to be, tax. This approach helps you to like manage your tax. So TF vectorizer is an approach that helps you to like convert, say your string, your combine strings together as, I mean, a numeric thing or an array that you can possibly pass, into the model you want to work with. So it's important to take note of approaches like this, because they'll be important, especially for people who wants to, at the end of the day, build like a model, for an NLP task. So approaches like this will just help you to get the number of times frequency a particular word is, showing, and you can always use that, replicate that approach in the task you're doing. So let's look at this in a simpler format. So we have DO, which is geek for geeks. So this is like a corpus of, string, D1 geeks, D2 R2G. So what we did there was to combine these 3 documents, say that way, these 3 data sets, together. And if we check string now, we're going to have a combination of geek for geeks, and R2G. So we have combined them together. All right. So the next thing we needed to do, so don't forget here, we also imported from sklearn.feature-extraction.text, we imported TF ID vectorizer. That's the module that we're going to use to achieve this. So here we set TF IDF.tf vectorizer. All right. We're initializing it here as an object. Instead of saying TF vectorizer, we always say TF-DF. That is, we're going to transform this guy. All right. And at this point now, the result now is going to be a space matrix. So we check the result now, is no longer just going to be showing geek for geek and all of that. we won't be able to get that. Can you see that? So it's showing a space matrix. So it is good at this point that we can pass in this kind of results into our model or into anything you're trying to do, but you cannot pass the text, the way they are, the strings the way they are into, your working environment, especially for people who wants to build a model and all of that. But that is why we're trying these guys out. So that means if I want to use this particular guy into my model, is the result that we pass. No longer, it's not going to be the string, so that it can be easier for me to process, my model. So for after these that we have, gotten a space matrix. A space matrix, is, an array, all right, that has a component and all of that. So if I want to get, what we have here now, I need to use a method called get feature name out to be able to get the exact feature, that belongs to a particular value. So that's what is happening here. So if I look at this now, 4 now, the IDF values for 4 is 1.69. The gigs has 1.28. The R2G has 1.7 thereabout. So for us to be able to have gotten for gigs R2G is because we are using the method called get feature name out. If we do not use the get feature name out, we cannot, access the name of this feature any longer, right? Because we have already, transformed our string into a space matrix. And of course, if you look at this now, it gives you a picture of the words and the value. It also gives a picture of how much a particular word exists, in the vocabularies that you're working with. So that's like a picture of what, TF-IDF help us to, to achieve. So if you look at the word we have, gigs is 1, 4 is 0, R2G is 2. So for 0 to 0, that is when you have 4 and 4, you have a 55%, of that value exists in your document. 0 and 1, this is when you have a 4 and Greek in your document, you have about 64%, of how much that kind of word, exists in your document. When you have a gigs for geeks, you have about 100% situation about how, that such word exists in your document. Then when you have your 2x2, which is R2G, so you have, every feature will be more like an 100% correlated to itself. So for people who have, some background doing analytical work before now. Okay, so finally on this tutorial, I'm going to quickly talk about sentiment analysis, because it's important to note that this is one big use case for us, especially for people who want to, venture into solving problems using NLP. So you have in mind that NLP helps us to do sentiment analysis. And what is sentiment analysis all about? Sentiment analysis is an approach that helps us, based on a given word, to identify, the kind of word that we have. So talk about, the election that happened in your local environment, talk about what people are saying about, for example, you can try to analyze, this conference and say what are people saying about, the DSC ADRIA, conference. All right. At that point, we want to know if it's good. So there are like 3, sensitivity that you will get whenever you do this kind of analysis. One part is that you will be able to say if it is a positive one. One part is that you're going to be able to say if it is a negative one. And one part is going to be to say if the person saying this tweet or writing this particular comment is being neutral about the process, right? And that's like, one good way of understanding what people are saying. And one module that helps us to be able to pick some of these, strings and, manage it well is going to be nltk.download Veda Lexing. So this is like the module that helps us to, to achieve that. All right. It helps us to achieve that by picking up this, so this is for more like for a service rendering company called Vexing Support. Then from this, we can see that we have like 3 different tweets about them. And with that module, we'll be able to see, what we have. So this is the tweet. So I'm saying that after what I did here was more like I have loaded the class sets. So for tweets in tweets, so the bob is a text bob, the tweet. So I want to get from the bob now, I want to get the sentiment of every of the tweets. The sentiment of every of the tweets. Now, for the sentiment of every tweet, it has a polarity and a subjectivity. For every text that you want to understand the sentiment it has polarity and also subjectivity. So the polarity is more like the polarity score. Subjectivity talks about if it is positive, if it is negative, if it is neutral, right? These are things that it tells you how that particular tweet is doing, all right? So let's go a bit more deeper to use a sentiment intensity analyzer from sentiment in NLTK to now say, okay, let's pass all of these guys, all right? And then let's know what their scores are. Now, if you look at the first, the first tweet that is here, it's saying that the negative part of that tweet is about 14%. The neutral part of that tweet is about 72%. The positive part of that tweet is about 14%. So for us, because we have to be able to conclude, all right, on what can we say about this tweet, all right? And that's exactly why this polarity score is important. And the polarity score, in conclusion, is more like a compound score. So this score gives us a picture, of what we can conclude in the overall. So if you have 0.05 here, that means we can conclude that this first tweet, all right, it's a neutral tweet. And of course, because that's like 72%, why? But 14% still talks about how positive that tweet is. Then, of course, as women, we can also come and read this, and as women, logically, we can also look at what we are having there. So let's say, dear at Vexing Support, your service is straight in dollars. I mean, that is a picture of, a bit of positive, right? I've been with you all over a decade, and it's all-time low for you all. That didn't sound nice. I'm talking no internet at all. All right, that's so. I mean, a bit of that talks about positive, a bit of that talks about negative, a whole part of that talks about I mean, the person is, no, at some point the person is not in any of the side with some comments. So that is why we can conclude this way. So the other one, I send you a DM. So I send you a DM is not enough, information to say the person is not happy or the person is not feeling good or the person is happy. I send you a DM is not enough to address the polarity score of such situations. So that's why we say the negative. So the score this module gave us when he did the analysis, the negative part of that is 0.0 neutral. I mean, takes on the 100% positive. So compound score here is 0.0. So that means we can conclude that the second tweet is a neutral one. So we have the neutral for the third tweet to be 0.7, neutral 0.75, positive 0.7. The compound, the calculation of these three guys is about 52%. So at that point, we can say that the third tweet from this complaint is actually a positive one. So these are some of the things you can achieve with this is one of the things you can achieve with NLP. So at this point, I like to take questions before I walk you through one or two real projects. Like I said, even if time will not permit us to go through the two, you have access to the materials here, that you can follow through with all that we've done. So I don't know if there are questions. I don't know if the team want to help me with that. Questions on what we've discussed so far on this call.
Hello, sorry, Israel, did you finish?
No, I'm not done. I'm asking if there is any question from any end. All right, great. So I guess there are no questions. We'll just go through this tutorial together. It's a project, and this could help us to understand what this it's all about. So I'm going to disconnect this so that I'm not running too much power. So disconnect this. Okay, yes. Okay, so this tax is from Kaggle, and because we need to all understand what the tax is all about. So I believe that a number of us have had to be on Kaggle, possible for getting access to a data set, or I mean, participating even in competition in some of the discussion and all of that. So you need to have a Kaggle account. So let me take this to, yeah. So if you look at the task, I think that's like one thing I wanted to show. Let me just share another part where I'm logged in so I can see what I'm talking about. Okay, good. So if you look at this part, now I'm in my account. So before I come back, yeah, this is what the tax is all about. So you need to like log into your account. If you don't have, you want to register an account. So this is my account. And here I can view, the tax we're talking about. So if you read about this, primarily they want us to be able to flag and identify a particular, quorum question as an insincere or sincere question. All right, that's like what they want us to do. So if you check through, because you have to understand the problem we're trying to solve. So if you look at this general now, I just want to show you the part. Okay, it says so when it has 1 is insincere, if it has 0 is sincere. So I mean that's more like we're trying to build a model at the end of the day, whereby we can predict whether it is sincere or not sincere. So in the few moments that I have, I will quickly check through, walk you through this, because there are a number of things that are involved. The first part is that if you are in your Kaggle account, you want to try as much as possible. For this tax, you don't need to download the data sets. So if you go into your account and go under settings, so there's something we call your API here. What this does is that it helps you to, like, since you're already on Kaggle, instead of downloading the data set, you just can create a new token. So it automatically create a JSON file and names it Kaggle for you, and it automatically downloads on your local system that you are working on it. So with that, you don't need to download the data set. You'll be able to access the data set using some code that we have there. So I'm going to go back to the interface we had earlier before now. Okay, good. So this is the task we're trying to do. So the task is that, so now I can connect, I can connect this. So text classification with bag of words is what we're trying to do here. Of course, we know what NLP is. We did a bit around bag of words when we're running through the tutorial before now. So you can download and explore this, apply some text preprocessing, implement bag of word. And of course, we're going to train the models for text classification. Then we'll predict and submit. Of course, we won't do all of this here because we're not trying to do the competition, but we're just trying to learn from the competition. So the next thing is that we're going to download a data set from Kaggle to CodeLab environment. We're going to explore the data using pandas. We're going to create a small working example. So the first thing to do, because you want to be able to access Kaggle in your CodeLab environment, you need to pip install your Kaggle. I mean, that's like the first thing to do. Yeah. Okay, so that is successful. Then the next thing is, if you come here, because I told you that it has downloaded a Kaggle JSON file for you. All right, so you need to upload that. So if your system might be here before now, so you come to this file. So you click on this upload sign. All right, so check where it is. It should be on your download if you just downloaded it. All right, so because I mean, this shows like I have a version before now. So I could just rename this so that it gives the name that is expecting. Okay, good. So I have this now. The next thing is I'm going to do an LS. An LS here will help me to see the directory I'm working and also the files that are available. So you can see that I have a cargo.json file. I also have a sample data. So we need to talk about OS here because we want to be able to access a number of things. So this sign here helps us to protect helps me to protect my cargo URL API. So this will help me to do that. So same thing for you if you do this. So it helps you to protect your account. So we're fine. So now this is the approach that we will use to download the data set if you have not. So we're just trying this. Let's see. So you can see it's downloading data set from Cargo for me using this approach. All right, this code is, just trying to download the train data, text data, and sample data. Okay. Of course, I want to load my data sets. So you can see here that I have 3 data that I'm working with. I have the train F name, the text data, the sample data. But for this task, we just need the train, we need the text, and of course, sample is because for people who are participating in the competition, you might want to submit that task. So then I'm going to import pandas as PD because I want to be able to load my data set as a CSV file or as an Excel file, depending on the kind of task you're working with. So here, I'm going to do raw df. So this may take a bit of time depending on how large the data set is. Okay, so I'm going to do .add to see the top 5 records. So in the data set, I have QID, I have question text, and I have my target. So the QID is here, the question ID, the question text, target. 0, when it is 0 means that it is sincere one, and it is 1 means that it is a not sincere. So I decided to, select all the data in my targets that has 0, which means sincere, into a variable called sincere. All right. So I decided to now check the top 10, of what a message or a comment that means sincere is. So we check this place now. So these are examples of, several examples of what a sincere question looks like. The same thing here, I did the same thing here to check example of what an insincere, questions are. Then I decided to also check the value count. These are some of the normal preprocessing you have done because it's an ML task even at the end of the day that you're trying to do on this project. So if we check this, I can see that my sincere, which is 0, has about 94% or thereabout. And I can see that my, 1, which is insincere, has about 6% and all of that. So I decided to also plot a bar chart to see the same information I just checked. I'm checking my text data. Right, yeah, so I'm creating a working sample of 10,000 of all the data that I have. And that's what I have here. Now, so this is the part I really want to show you before we close, is the preprocessing approach, all right? So we did that on, few data. So from here, let's say, okay. Let me load this part. Just trying to do this on, just one data to see what we are trying to do. Tokenization. The tokenization we did here was a word tokenization. We also use Pocket because it's a module that will help us to do word tokenization. All right. So when I did tokenization, okay, this is when I did tokenization. You can see that word tokenize. You can see the result I got when I did word tokenize. The Q1, you can see same thing that has happened on question 1. Word tokenize on question 1. So I've taught my, word tokenize for Q0, which is sincere word tokenize for Q1, which is insincere. The next thing to do is to apply stop words. In order to show you this flow so that you can see that the things we have done earlier are the things you will do on any kind of data you're working with, as far as it's an NLP task. So I've also here, I've checked all my, stop words. So here, I read a function to remove all the stop words that I have. And that is being stored in Q0 underscore stop word. So from my sincere, word, I'm removing stop word from it. That's primarily, what we have here. So my Q1, same thing, I'm removing stop words on it. So just trying to show you, can you see the things we've done before now and we're doing them again? So the approach will not change. It's still like almost the same thing everywhere. The preprocessing will not change. Just that what we're trying to achieve as the goal at the end is what changes. So stemma, all right. So we have this, the method we are using here is snowball stemma. You have the stemma.stem, on a particular word just to see if that works. So I applied this on the stop word that I have already. So now that I've done my stop, I'll remove my stop word. Now when I do my stemming, what do I have? I have adopt, dog, would, encourage, people, adopt, shop, question mark. So that's what I have here. So I decided to also do lemmatization. I told you the lemmatization is going to do much better than, possibly what we have before. But this time around, we did not just do some sample here. Now, the sample here is just some few data that we have is what my samples are. So my sample, I'm just selecting just 5. Just trying to prove concepts. Okay, sample data is not defined. That means there was a place where I loaded sample data that I have not run in all of these. So let's say that again. Okay, I think it's here. Did not run this. Okay, so this is it. Just trying to identify, my code. And these are things that you need to understand. Look at where it's asking me that I have not. So I also noticed that I did not completely run each of those folks. Okay, good. So if you come here now, so from this sample data, I'm just selecting 5 of it, just to be sure I have some information I can work with. Good. Why we're doing this is because learning all of them, 100,000 record might take time. So what I did there was to introduce a CAN vectorizer, which what the CAN vectorizer does is that it helps us to calculate more like the similar, helps us to do a picture of what we did the other around bag of words. It picks a word. So yeah, I use CAN vectorizer and I fit these guys, all right, question text, because I cannot, work with a string and then to have, converted that string to a space matrix. So this also helps us to identify that. And of course, if I want to know what those texts are, I can use the method called get feature name out, to get that. So I've transformed my document here to a vector, because this vector we need to pass into my module, all right, especially when I want to build the model. But yeah, I can still see what it is. So for what is the most effective classroom and all of that, if I check the vector of this word, you can see what this same word, how it is being represented in vector. All right. So that is all that is happening here. Also, before doing my CAN vectorizer, I can decide to also do stemming on it. I'm just showing you, different ways of utilizing the things we've done before now. And one key thing here is I can see that in my CAN vectorizer, we decided to pass in a number of parameters. Lowercase should be true, tokenized should be tokenized. This is the function we wrote already. Stop word, English stop word, maximum, features you want to have here is just 1,000. So you can see it's taking time to run to, fit this. Why? Because the number of things that are happening, in the background. And that is why at times we don't want to run, especially for tutorials like this, complex or large data sets. So that being done, the next step to do is going to be about the machine learning model. But of course, this class is not discussing machine learning model, but I know that we are aware about how our machine learning model works. The next thing is to split our data. So if you look carefully on what the inputs at this point are not just the real data. The inputs are data sets that we have actually worked on. So look at the inputs here. They are the, it's just those texts, which are the comments, so which have been transformed. And that's exactly what I was saying when we were, talking about this earlier. So we have to vectorize our data such that we don't pass in the string any longer. We are passing in like a matrix, all right, into the model. And of course, the target, because the target is already numbered, so we don't need to do anything on the target. So it's good at 0 and 1, and that's why we have here. So if the text size is 30%, that means we are training with 70%, and the random state is 42, meaning that whatever data are splitted to at this point, it should retain those random splitting. So we have trained with 70% and we're testing with 30% of the data. And of course, we tried a number of model logistic regression. We've checked the result we have on logistic regression. So the accuracy of how much this model has predicted was about 95%. Then, we also checked the F1 score, which says 45%. All right. And of course, so accuracy, again, when we check on the validation score is 94%, 40%. So, I mean, it depends on, the metrics we're trying to do. Like I said, we're not really trying to do a lot of machine learning now, but it's not a bad idea, the result we are getting, even when it has predicted these guys or not. But one key thing is that, I mean, it has learned a particular pattern too much because a particular pattern has so much, results. So a number of messages already shows insincere, right? So if we did not, undo that kind of case, which it talks about imbalanced classes, but like I said, we're not doing all of that here, but we just want to see how the process can flow whenever you have to do, a classification problem, specifically for an NLP task. That's, really in real time, the things that we're trying to do here. All right, so this is just a proof of concept to the things that we've learned in this class, which already shows that with this knowledge, you can actually pick up a data set that has to do with NLP, and you can, do some of this cleaning that we've done. Then, it depends on what your end goal is, if it's to, build a model or if it's to do sentiment analysis. I'm just going to finally show this in few moments, then we'll stop here. Let me disconnect this and just show you this car sentiment analysis project. So same thing here. So it depends on what you're really doing. So if you look at this, you have, a number of modules have been implemented for the task you're trying to do. Here, what to do sentiment analysis based on what people are saying, the reviews of what people are saying. All right, what to say if it's a good one about the cars, if it's a bad one. So the first set of action here was to load the data sets. We check if they are missing data. Here I dropped, if they are, and I dropped a column I felt was not necessary. I tried to also round up that there are no need for having rating in decimals. I checked the number of records and columns that we have. Check their missing data. All right. Now, so this case, it's a bit easier because in the data set we are working with here, we already have rating, and that rating makes it a bit easier to know what has been, what kind of thing are people saying. But let's say that we don't have rating. But for this task, since we have rating, we leverage on rating to say it's a positive one, it's a negative one, or it's a neutral one. All right. Then we did some plotting, of what people are saying. And of course, this is exactly what I want to show. This is a stop word. So what word cloud does? This is a word cloud. What the word cloud does is that it helps you to give a pictorial form of what people are saying in respect to the task that you've done, right? And that is, an example of what we have here. So you can see what people are saying about your car. You can also decide to filter it. Is it negative? Is it neutral? What are people saying that are negative? What are people saying that are neutral, that are positive to what we are doing? Then, and of course, this part, which is like the key part of what we have tried learning today, is the part where you have to clean your data. So here we have to convert the text to lowercase. We have to remove word enclosed in square bracket. We have to remove word enclosed in angle bracket. We have to remove hyperlinks. We have to remove, URLs. We have to remove numbers. We have to remove stop words. These are the preprocessing we're trying to understand. And doing this makes it very, very easier for you, as a data expert, as an NLP expert, to be able to jump on any data-related project or task that you might have. So this is just what I wanted to show, for you. And of course, you can also decide to use the VADA Lexing method that we did the other time to calculate, based on the review, the polarity score, the sensitivity of, the task. All right, so once again, thanks to everybody who has joined this call. And I hope there are questions. At this point, I would like that you can connect with me on LinkedIn. And maybe, it's a bit very difficult to get feedback from us here. So this is my LinkedIn name. You might want to reach out to me. If you have questions or other things you might want to need clarity on, I'm always, very much, there to check out. So please, you can connect on LinkedIn using D's name. So at this point, I'd like to also take questions or feedback on this section. Thanks, everyone.
Do anyone have a question for Israel? Again, do we have questions? We can have one question in the chat, so Israel, you can see where we can access the materials used in this presentation. We will share this presentation with all our attendants. Yes,
I did that already. I don't know. Let me reply to this question. I shared that in the chat. I don't know if you got it. I'm sharing again in the chat. I've shared a number of times. I'm sharing again. Hopefully it gets to you. Yeah.
Yeah, we can see your link.
Yeah.
So if that's it, thank you for your time, Israel. We will share our presentation, as I said, and thank you for your attention. We will now have a break. The next tutorial begins at 2.